Hey guys, it's Mr. Lowry. You should have spent the last maybe 20 minutes or so working in groups on this assignment here, systems of linear equations. And we have a scenario here where we're going to be selling soda. Okay. So you've worked through this with groups, you've talked about it a little bit. We want to just kind of double check and make sure you're on the right track, and so this is, we're just going to kind of go through this really quickly and then see how this applies to today's lesson. So right now here, the first thing we're going to talk about is breaking even. So whenever you have like a business, you have costs, things that you have to pay for, and then you also have money coming in because you're trying to make money. So breaking even is when the money that you're getting is equal to the money that you're spending. The money coming in equals the money coming out. Something to that effect. So what I wrote here is breaking even means you've made back all the money you spent. Or another way to write it is it's the point where your cost equals your income, or you could also say costs equals revenue. Revenue is another word for money coming in. So that's kind of the idea about breaking even. Okay. Part B here, we're looking for an equation for cost in dollars. So this is a little tricky, but what you got to do is you got to look at two different costs. Okay, you have a fixed cost, which is this $12 here that you pay one time to get that cooler. Okay, now you actually have to do a little work here to figure out how much you're paying per can, right? So you're buying 12 packs of cans. So if you divide $3 by 12 cans in a pack, you get 25 cents, 0.25 or 0.25. So basically you're paying a quarter for each of these cans. So here's the $12 that you pay one time for the cooler, and then anytime you pay for an extra soda, this is what you're paying per soda. So there's two pieces here. This is kind of like the y-intercept, and this is like the slope here. Okay, now keep in mind that 0.25 as a decimal, it makes sense, it's 25 cents, right? But later we might want to turn that into a fraction, 1 over 4, so we can graph it. So what this would represent is every time we go up, $1, we can get 4 more cans of soda, or $1 is 4 cans of soda. So they're like, they're 25 cents each. Okay. Next down here, part C, we have our income. So I use I for income. You could also use R for revenue if you wanted to, or you could use another variable. But since we're selling these for 50 cents each, we're going to make 50 cents for the number of cans of soda we sell. So if we end up selling, 100 cans of soda, we'll make $50. Okay, there's no y-intercept in this case. Okay. Now for the graph, I gave you some kind of specific instructions, and if you don't follow them, then your graph is going to maybe not fit on the paper. So this is more or less what your graph should look like. Let me see if I can zoom out here really quick. Okay. All right. So down here I have number of cans, and I just let each line equal 1 can. So 1, 2, 3, 4, 5, 6, right, and so on like that. And then this is my money in dollars. I let each line equal $1. Okay. If you do it that way, then you can actually use the blocks to count the slope. If you scale this differently than this, like if this doesn't go by ones and this doesn't go by ones, then your rise and your run gets thrown off. So if you went by like 5s here and like 2s here, you wouldn't be able to use rise over run the same way, which is why I had you do it this way. Okay. So when you're graphing each of these equations, the first one here that I graphed was my costs. Okay, so this is the cost equation. So notice I start at 12. This is 12 right here. Okay, that's my y-intercept. And then I basically went up 1 and right 4, up 1 and right 4, up 1 and right 4, up 1 and right 4. Okay, so that's how I got the other pieces. I've just used that slope. So we're talking about this guy, right? 0.25 is the same as 1 over 4, 1/4. So 1/4 x plus 12, right? That would be up 1, right 4, starting at 12. Okay. The other one down here, this is the income, or also known as the revenue, how much money you're making. Okay. So I started at 0, and then I go up 1, right 2, up 1, right 2, up 1, right 2. Again, kind of converting this decimal 0.5 to a fraction, 1 over 2. So this would be $1 for 2 sodas, or every time I go up $1 $1 in income, that means I've sold 2 sodas. So that's kind of what's going on there. So when you graph these, this is a system, right? We've been talking about systems of linear equations, and here's their intersection point right here, okay? It's at 48.24, and this is 48 on the X. That's number of cans, right? So 48 cans, and that's $24. So when I sell or buy 48 cans of soda, it costs $24, and I make $24 at the same time. So this is the solution to the system, which is actually my break-even point. The cost for buying 48 sodas, including that $12 cooler, is the same as the cost for selling 48 sodas. It's $24 either way. Okay, so that's kind of the whole point here. The point is to apply the idea of systems of equations to like a real-world scenario. So going back to this guy right here, you should hopefully have something like that too. So this is the solution, 48.24, right? The cost for buying 48 cans equals the money that you get for selling 48 cans, which is $24. Okay, so 48 cans, $24. That's kind of the idea. Now something to talk about just really briefly is really, if you think about it, these graphs should actually be discrete. Because you can't buy half a can of soda, you can't sell half a can of soda. So we would actually probably not connect these dots, but in order to find the intersection point, it might be a little easier. That's why I used lines. But actually, you'll notice I only put a few points on this cost graph, and the reason I did that is if you're buying 12 packs, you can't buy anything less than 12 cans of soda, right? So I was thinking, okay, look, if I buy 12 cans of soda, that's $3. So this actually goes right 12 up 3, right 12 up 3, and that kind of represents this guy, right? I'm buying 12 packs. I'm buying 12 cans at a time. So if it was really, really super, super accurate to the scenario, I would really only have dots here, 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 and here. And then likewise for the number of cans, I can't sell half a can. I can only sell 1 can at a time. So really I should have dots in between here, but no line. So I would have a bunch of dots, but without a line. But for our purposes here, we're talking about, graphing and finding intersecting lines. I thought it would kind of make sense to keep those lines just so I didn't confuse you guys too much. But just something to think about with the discrete versus continuous that we've talked about in class before. Okay, now the rest of this, the next side here, I just wanted to help you through. This is going to kind of be for your notes here today. But we're going to keep going kind of with this same scenario, but I want to show you how to solve a system with a different method, okay? Graphing is one method to solve systems. Graph the 2 equations, find the intersection point, right? We can also do it algebraically, which is what we're going to kind of practice today. So now you should have this piece out, and we're going to kind of go through this together. If we need to pause the video at some point, to stop, let everybody catch up, or to ask questions, please feel free to do that. I'm going to go ahead and jump in here on part 2. So we're talking about the same system, right? So this is part 2. Imagine we're the same scenario here, okay? So let's go ahead and just write our system first. We have cost equals 0.25x plus 12, and then we have income or revenue equals 0.50x, okay, something like that. Okay, now what we know about breaking even is it's where cost and revenue are equal to each other, right? We want cost or income, cost, income or revenue are kind of the same idea. We want cost and income to be the same. Okay, so this is what happens at the break even point. Okay, and it's kind of like this intersection point that we were talking about earlier. So what we would do algebraically is we would actually just take this one and set it equal to this one, right? So what is C? C is actually 0.25x plus 12. So I'm replacing the C variable with the expression that it's equal to. Okay, what is I equal to? Well, we have this expression as well. I is equal to 0.50x. Okay, so this is called substitution because I replaced C, the cost, with the expression that it's equal to. And I replaced I the income with the expression that it's equal to. And notice that when I did that, I have one equation that only has x's in it. Okay? And so from here we can solve for x. We can actually do it pretty easily. We want to get x by itself. Okay? So check this out. I'm going to subtract 0.25x from both sides. Okay, trying to get all the x's together. So that's gone here. I get 12 equals 0.25x. So when I subtract 50 cents minus 25 cents is 25 cents, right? Okay, so now I want to divide both sides by 0.25 because I want to get x by itself, right? So here they're going to go away. Now I just got to figure out what 12 divided by 0.25 equals. Okay, now there's a way you can do this with fractions. If you wanted to change it to fractions, and you could do invert and multiply, you could do that here. But I'm going to grab a calculator really quick. Okay, so let's do this together. I got 12 divided by 0.25. Okay, and it's 48, right? X equals 48. Well, what was x in this case when we were talking about cans and money? It was cans, right? So 48 cans. All right, cool. So that's how you solve by substitution. It's just an algebra way of doing it, okay? Now if we wanted to find out like what amount of money, we would have to take this and actually plug it back into one of these equations, right? So this is a number of cans. Notice this is not a solution yet, because a solution is an ordered pair, right? My solution was 48 something. If you turn back to the page, you'll remember what that is, but we're trying to solve it a different way here. So 48 is the number of cans. Now if I plug that here, I should have the income is equal to 0.50 times 48, right? The money that I'm making is 50 cents per can times 48 cans. And if I multiply that, 0.5 times 48, I get $24, right? My income for selling 48 cans is $24. Okay, but similarly, if I wanted the cost for that many cans, I would have 25 cents per can times 48 cans plus that $12 for the cooler, right? Well, let's see what that is. 0.25 times 48 cans, so 25 cents per can times 48 cans. $12 for the soda alone, plus the $12 for the cooler, cost equals 24. Notice it's the same. Well, of course it's the same, right? We actually were trying to find the point where the income and the cost were equal. So 48 cans is how many you need to sell to break even, but that's going to end up being $24, right? So either C or I equals $24. So our solution would be something like this, 48.24, right? There's two parts to it. Okay. Let's apply that to just some regular problems that don't have any context for them. Okay, that's solving by substitution, but let's just do some example problems here. So take a minute to write down example 1. Okay, notice we have two linear equations. They're both in slope-intercept form, and we're going to solve by substitution. So notice that we got a y equals and a y equals. Okay, well, if those y's are the same y, then that means that this should equal this, right? In other words, I have, y is equal to this expression, but y is also equal to this expression. So I can replace this y with whatever y is equal to, okay? So what I can write, just kind of like I did up here, I had two different equations, both equal to some letter. I can say that 3x plus 14 equals negative 4x. Okay. In other words, this is kind of the obvious part, but I know that y is equal to y, right? It's the same y. So I can replace y with this expression, and I can replace y with this expression. So if both of your equations are equal to the same variable, just set the two longer expressions equal to each other. Okay. Now we're going to solve for x. So we just have an equation with just one variable here. Sorry, I shouldn't box it. That's usually what we do for answers. I'm just trying to highlight where we're at here. Okay. So let's get all the x's together. Okay. So I'm going to subtract 3x from this side, subtract 3x from this side. So 14 equals negative 7x. Okay. We need to divide both sides by -7 to get x by itself, so -2 equals x. Okay. Now remember, I'm trying to find a solution to a system. Okay, so I'm not done when I find that first variable. I'm looking for something like this, right? I still need the other variable. So what I have to do is I have to plug this number back into one or two of these equations. It doesn't matter which one, they're actually going to give me the same thing, and I'm going to actually show that that's the case. So let's substitute back in. Let's take this and plug it back in to see what my y is. So y is equal to 3 times -2 plus 14. Oops, sorry, too many parentheses there. Which would be -6 plus 14. And that would be equal to 8, right? Okay, so according to equation 1, y is equal to 8. Okay, let's just double check with equation 2. So y is equal to -4 times x, and I know x is -2. Okay, so I got, let me write this a little bit bigger so you guys can see it better. -4 times -2, yeah, that's 8 still. So either way you get 8. Okay, so the method here is replace one of the variables with what that variable is equal to. Replace that variable with an expression, solve for the first variable, and then plug that in to solve for the second variable. Okay. Let me show you in your book what that looks like, in case you need some extra help. This is on page 224, and it's in section 5.2. Okay. So this is the core concept. These are your steps. Okay, first, solve one of the equations for one of the variables. Okay, now if you look here, these equations are already solved for one of the variables. In other words, you want to have an equation where a letter is by itself. So y is by itself here, and y is by itself here. Okay, so that was already taken care of for us. Step 2, substitute the expression from step 1 into the other equation and solve for the other variable. Okay, that's kind of tricky, but what they're saying is we're going to take, substitute the expression from step 1. So we're going to take whatever is solved for here, and we're going to replace something in the other one, right? So we took this y, and we replaced it with this expression. Okay, then we solved for x, and then step 3, substitute the value from step 2 into one of the original equations and solve. So that's a little bit confusing. Let's run through those steps again and kind of highlight them as we go, and we're going to do that with example 2, okay, that I have right here. These actually I grabbed all from your book, but we'll just do them right here. Okay, so step 1, we have to make sure one of the variables is solved for a variable. Okay, so when you look at this equation 2 here in example 2, notice that there's not a variable by itself. Okay, there's an x and there's a y, but none of them is isolated. Okay, but if you look at equation 1, you have a variable isolated, which is what we want. One of the equations needs to have one of the variables isolated, and in this case it does in example 2. Okay, so you're going to take whichever one that's solved, and you're going to basically substitute the expression into the other equation. Okay, so think of substitution almost like a recipe. Okay, so right here we have a recipe. Okay, it says we need 6 x's and -5 y's, and we get this. Okay, now imagine you're cooking something, right? And it asks you for like an egg, and you're like, okay, I don't have an egg, but you look up this substitution, and it says you can replace an egg with 2 tablespoons of applesauce. Sometimes people do that in like vegetarian things. So every time in the recipe that you see an egg, you just replace that with 2 tablespoons of applesauce. Okay, so this is basically saying, hey, every time you see a y, if you want to, you can replace it with this stuff. So when you read your equation, okay, 6x minus 5y, you see that y, and you're like, oh, that y, I can replace it with this stuff right here. Okay. So a little tricky, but we take this equation And we take this expression, we say, okay, if y is equal to this, then in this equation we can replace that y. So we rewrite, we got 6x minus 5, but we don't write y. Okay, instead of writing y, we write what y is equal to. Negative 2x minus 9. Okay, so notice that this equation and this equation are the same thing. They're the same equation, right? Except instead of a y, I replaced y with an expression, because this is what y is equal to. Again, it's like writing a recipe, but when I hit y, I'm like, you know what? Don't have any y's. I replace that y with what it's equal to. I substitute, okay? Just like in a recipe where you substitute an ingredient that you have for an ingredient that you don't have. So imagine you're writing this out, you don't want to use y's, so you replace y with some other stuff. All right, now from here we can solve for x because we don't have any other variables, we just have x's. So we're going to start by distributing this negative 5. So negative 5 times negative 2x will be plus 10x. Negative 5 times negative 9 will be positive 45. So don't forget to distribute the negative there as well. Equals negative 19. Okay? All right, now combine like terms, right? So 6x and 10x together give you 16x. So we got 16x plus 45 equals negative 19. All right, now it's just a two-step equation we need to solve. So subtract 45, subtract 45. Okay, and we get 16x equals, I'm just going to double check this in my calculator because the numbers are a little bit bigger than I'm comfortable with doing in my head. All right, so this equals negative 64. Okay, divide both sides by 16, and we get x equals negative 4. Cool. Okay, now we're not done yet because we need to find the y as well, right? This is a system of equations. It should have, the solution should have two parts to it. It should be an intersection point, okay? So we take this thing and we got to find out what y is. Now we could either plug it back in here to this equation or to this equation. What I showed you before was basically that it doesn't matter which one you plug it into, you're going to get the same value out. So you pick the one that it's going to be the easiest to use. And in that case, I think it would be equation 1. Okay, so y is equal to negative 2 times x, which we know now is negative 4, minus 9. Okay, so y is equal to negative 2 times negative 4, positive 8 minus 9. Okay, and then 8 minus 9 is going to be negative 1. All right, so now we have two pieces. We have the negative 4 that we got, and then we got the negative 1 that we got. So negative 4, negative 1 is our solution. Okay. So going back to those steps, I know this is kind of tricky here, but we started with one of the equations already solved for one of the variables. We already had y by itself. Okay. Then we took that expression, the expression from the y part, and we plugged it into the other equation. So we took this expression for y and we replaced the y in the second equation so that we only had x's. Okay, we solved for x, and then once we had x, we plugged it back in. Okay, let's take a look at example 3 now. Okay, now what I want you to do is I want you to see if you guys can do this kind of on your own. So I'm gonna kind of get you started here, and then I want you to take it from there. So notice that the first thing we have to do in those steps is we have to make sure one of the variables is isolated. So if you look at the second equation, none of the variables are by themselves. We don't have like x equals or y equals, but the first equation does. Okay, so in this one, we're actually going to replace x. All right, so one of the equations is already solved for a variable, solved for x. So what we're going to do is we're going to rewrite this one, but we're going to replace the x with what x is equal to. Okay, so pause the video now and see how far you can get on that. Okay, you should be coming back from the pause now. So let's write this out here. So I'm going to take this equation here, the second one, and I'm going to replace the x. Okay, so again, imagine this is a recipe, but I don't have any x's to use, so I have to replace it with something. Okay, if I don't want to use x, I have to use what x is equal to. In this case, 6y minus 7. Okay. All right, so notice I got 4 times x, plus y equals negative 3. So this equation here and this equation here are exactly the same. The only difference is I didn't use x here, or I used an x here, and here I replaced that x with what this first statement said it was equal to. Okay, so I replaced it with this guy. Okay, so I should get, when I distribute here, 24y minus 28 plus y equals negative 3. Okay, combine like terms here. I got some y's and some y's. So 25y minus 28 equals negative 3. Okay, I'm going to add 28 to both sides. So I have 25y equals 25. Sorry, come off the page here. Divide both sides by 25, and I get y equals 1. Okay, so that's part of my answer. Remember, I need both pieces. So what we need to do is take this guy and plug it back into either of these equations. It doesn't matter which one, you get a pick. However, I'd pick the one that's going to give you x the easiest. And in this case, this is going to be the easiest right here. It's already solved for a variable. Okay, so that means we're using the top one. X equals 6 times 1 minus 7. Right? Okay. So x equals 6 minus 7. 6 times 1 is 6. So x equals negative 1. Okay, so now I have both parts. My solution here is going to be negative 1, 1. Now be careful when you write your answer. Remember that even though I solved for this first, this y equals 1, it's the y variable, so it goes in the second position. Okay, and I got x equals negative 1. So this is my solution for number 3. Okay, so take a look at number 4. Now, at this point, you're probably getting short on time in the lesson, so if you need to, you can finish watching this video at home. It's going to be in Canvas. But when you look at example 4, what you'll notice is there's not a variable by itself yet, right? Neither of these equations has x equals or y equals. And so we have to start by getting one of those by itself. It actually doesn't matter which equation you use or which one you get. You just kind of pick what's going to be the easiest for you. Okay, so in this case, what I would do is I would probably solve the top one for y. I would get y by itself. Okay, so if I have negative x plus y equals 3, what I'm going to do is I'm going to add x here and here, and y equals either 3 plus x or x plus 3. Okay, so I just rearranged it, right? Solving a literal equation, you're just rearranging the variables. That's all we're doing. So this is now equation 1 right here. Get rid of that one. And this is equation 2. Okay, now I'm ready to substitute, right? So I can take this stuff and I can put it right here. So I'm going to rewrite equation 2. But as soon as I see a y, I'm going to replace it with this. So 3x plus y equals negative 1. I just replaced y with x plus 3. Okay. Combine like terms, 4x plus 3 equals negative 1. So 4x equals negative 4. If I subtract 3 from both sides, divide both sides by 4, and x equals negative 1. Okay, now we're not done yet. That's half of our solution. We got to take this value, we got to plug it back in either to this one or to this one, doesn't matter which, but we want the one that's going to give us y. So probably this guy. So y is equal to negative 1 plus 3, right? X plus 3. But since x is negative 1, it's negative 1 plus 3. So y is equal to positive 2. So my final answer here, as a point Right? Remember, these are intersection points, is 1, 2. All right. So those are some examples of how to solve a system by substitution. Okay, that's a little bit of algebra, and the hardest part is the replacing part. Once you replace a letter with an expression, it's not too bad from there. So your homework is going to be doing some of those problems from the book. In Canvas, I will post another video that kind of maybe walks you through 1 or 2 of those, because I know these can be a little bit tricky. All right, I hope you guys are having a great day, and I hope to see you next week real soon.